my project, I went and got this kit from Connects and made this awesome Ferris wheel. And then I went ahead and decided that I wanted to add lights and motor control. So as you can see, lovely lights. So we've got a lot of kids that are into apps and everything else, and anything with a screen, really. But we really need to push kids to be involved in STEM stuff, especially little girls. Girls are just as capable of being able to do engineering or math or science. As a mom, I want to be able to help my daughter be a well-rounded person, not just grow up the way I did, where I was pushed very strongly towards arts, and I like to be able to merge those together into one cohesive function. And that's partly what led me to want to do STEM in general, or STEM toys in general, because STEM toys, you're trying to get a kid's attention. I've gone through and this part here, if I can get it off, I went through and designed this piece to work with the Connects, you can see, to hold these lights in place. And then I've gone through and made it so that the lights are programmed with 10 different light patterns that will just cycle through unless I have a switch not turned on, and then it'll just stay on the one pattern. But I've gone through and coded each individual light and be able to see that in my mind of how I wanted the lights to work together. And then there's this silver axle right here. That's actually made of aluminum because I attempted to 3D print it and it just wasn't quite strong enough. So this is a slip ring, which means that this is free to rotate while this does not. And what happens is there's wires in the center of this, making it so that the motor and the lights are all controlled with one Arduino instead of having a whole bunch of microcontrollers. And what I would like to be able to do ultimately is make it so that there's an app involved with this, that a kid would be able to make the lights do what they want, so that they could get the programming side of it as well. I've used existing Connects pieces to make a user interface. So I've got an on and off switch for the motor, which, as you can tell, turns the motor on and off. The second one changes direction, so now the motor will go the opposite way. And then this is the switch I was talking about earlier, that if I have it flipped on, it'll cycle through the 10 patterns. And if I have it turned off, it'll stay on one pattern and just cycle through its color scheme. And then this one here, this is called a potentiometer, and it changes the speed of the motor. So I can slow it all the way down. Or speed it back up again. It's all controlled with this Arduino. And then we went through and made this breadboard and soldered it so it's all permanent and fixed in place. Because these are LEDs, they're one directional. It's a diode, which means that the current can't go one direction versus the other. And so it would be very important for them to make sure that they plug it in the correct way. So what I went through and did was I made it so that these are all plugs, and there's a male end and a female end, so that it will only plug in the way that it, has to go. So they can't plug it in backwards so that it won't work. I want to work for a STEM toy company. That's what has been my goal from day one of switching over to mechanical engineering, because I didn't start with mechanical. I started with graphic design, and I realized very quickly that I love art and I love being able to put my hands on something, but I'm not as driven with that as I am with my math and my mechanical side. So I want to be able to help, especially little girls, but little girls and little boys, see that in themselves and realize that just because, you may not be the most mechanical person to start with, you can be. Or maybe not mechanical, maybe it's science, maybe it's technology. It's whatever, you're drawn to, you can do it. And children learn through play, and I think that's how we have to help them figure this out. design definitely helped because I learned that design is a huge iterative process. It's not just a one and done and it's gonna work right away. And you know, I think one of the big things for me is I worked in the machine shop on campus, and I learned a lot of hands-on skills, from welding to using a mill or a lathe or basically any power tool around. And it helped me be able to put this into action, not just have a drawing on paper. I feel like we have a STEM crisis right now. We've got all these kids who are just mesmerized by a screen, yet they don't know how any of it works. They don't want to know how any of it works. I've got a niece who goes, I hate science. Science is stupid, as she's sitting there playing on her tablet. You know? And we're gonna hit some hard times if we can't up our game a little bit. So we can't just let them be entertained by a screen. We need to show them how to get hands-on and mess with this stuff. And that's what I think STEM toys are all about, is getting these kits that you build and you follow the instructions, and then you take it apart and do your own thing. You build your own thing and you figure out what works and what doesn't. And so I think that's why this is important. And you know, I'm really excited to be able to help that, you know, and I want to be with Lego or K'NEX or Hexbugs or Vex or whoever, but I want to help. I want to make a difference for not just, you know, all the kids, but for my kid.